Welcome, ladies and gentlemen, to our podcast. I'm Garima Batra, your host, and joining us today is a distinguished expert in the field of cannabis testing and accreditation. Please extend a warm welcome to Morgan Keefer, Accreditation Officer II, American Association for Laboratory Accreditation. As an accreditation officer with A2LA, Morgan brings extensive experience and knowledge in ensuring the quality and accuracy of cannabis testing procedures. Today, we'll delve into an important aspect of cannabis testing, which is proficiency testing, exploring its challenges, significance, advancements, and more. Welcome, Morgan, and thank you for being with us.
Thanks so much. I'm honored to be here, and I really appreciate the opportunity to discuss something that I'm personally so passionate about and that's so important for the industry.
Thank you, Morgan. Thank you. We are so excited to have you. Morgan, to begin, for those tuning in who might be unfamiliar, could you break down in simple terms what proficiency testing is and why it holds such critical importance for cannabis testing labs?
Certainly. So, proficiency testing actually occurs in many industries across the board for a lot of different product testing for consumer safety. This happens in the food industry, the petroleum industry, drinking water, and more. This is especially important for the cannabis industry because most of the test methods that are used are not yet standardized, or they could be modified test methods. And essentially what proficiency testing is there will be a sample that has a known concentration of a specific analyte or compound. And now these compounds are regulated in various industries. So for the food industry, these could be microbial contaminants. For the cannabis industry, each state kind of comes up with their own regulatory limits for analytes, and then in the petroleum industry, they can test for like octane index and things like that. But the idea generally is that a sample of that material is sent out to multiple participant laboratories. This could be tens or hundreds of laboratories depending on the test and depending on the industry. But this sample would have a known concentration of a specific analyte. So let's say we're testing for a pesticide. This sample could have 100 parts per billion of that pesticide, and that would be sent out to multiple different laboratories who are all using their own methods to test for that pesticide. And all these results would then be compared statistically by the provider, and a pass or fail value would be determined for each laboratory based on their specific result. So again, this is especially important for cannabis because laboratories are using these internally developed methods. So unlike food and petroleum, where most laboratories are working off of one method that has been optimized and developed over decades, for most of the cannabis labs, they're actually developing and validating their own methods. And the last point here is that currently in 2024, due to the federal illegality of cannabis, each state operates and implements regulations independently due to the federal law, and additionally, these high cannabinoid samples can't cross state lines legally, which brings additional challenges for the cannabis industry specifically in testing and receiving of these samples.
Thank you, Morgan, for that insightful explanation. Now let's get deeper into the specifics. Morgan, can you highlight some specific cannabinoids, microbial, or chemical attributes that cannabis testing labs typically test for during proficiency testing? And also elaborate on why these parameters are of such significance.
Sure. So some of the cannabinoids that are routinely tested for would be delta 8 and delta 9 THC, THCA, CBD, CBN, a lot of the cannabinoids that a consumer would see on a label. Additionally, some chemical attributes that are tested for are terpenes, which are usually also seen on the label that a consumer would purchase. And they can make their purchase decisions based off of some of these values. Additionally, the dispensaries do have interest in what these values are because they're going to be selling this product at the end of the day. The other tests that are done by cannabis laboratories are largely for consumer safety purposes. So this is things like pesticides, heavy metals, microbial pathogens, and some specific pathogens of interest that are routinely tested for are E. coli, Aspergillus, total yeast and mold, and Listeria. And then there's also specific types of bacteria or specific, like E. coli that produces STEC, for example, which can be tested for in specific edible products. And these are all, again, depending on the state regulations. The chemical test would include things like limonene and linalool and beta-caryophyllene, the terpene percentages, and then some of the other contaminants, they have actual limits associated with them for each state. So in one state, the flower might not be able to be sold in a dispensary to a consumer if it has more than, let's say, 10,000 colony forming units of total yeast and mold per gram. But this varies from state to state, so it's actually quite variable right now as to what the limits are in each state and what the analytes that are required are in each state. Some states also do have a list of required terpenes. I've seen up to like 50 terpenes be tested for, but yeah, so they're finding new stuff all the time. And additionally, they will test for some things such as flavonoids, which is kind of newer, or vitamin E acetate, which has been a consumer safety concern. So I'm sure that the list of analytes is just going to grow as we learn more and as the industry matures.
Yes. Thank you for providing such a comprehensive overview, Morgan. Now, let's shift our focus to ISO 17025. Morgan, could you enlighten us on the proficiency testing and interlaboratory comparison requirements essential for ISO 17025? And more importantly, could you share some best practices for cannabis testing labs to effectively prepare for proficiency testing?
Sure. So for ISO 17025, which is a internationally developed standard that cannabis laboratories are accredited to in many states, the bare minimum requirements of the standard are as follows, and this was a direct quote. So the laboratory shall monitor its performance by comparison with results of other laboratories, where available and appropriate. This monitoring shall be planned and reviewed and shall include, but not be limited to, either or both of the following: participation in proficiency testing, participation in interlaboratory comparisons other than proficiency testing. So the standard that these laboratories are accredited to in all industries, by the way, not just in the cannabis industry, is that the laboratory shall be, at the very least, participating in proficiency testing for the methods that are on their scope. That being said, there is a policy that each accreditation body, including A2LA, has on proficiency testing, and this is determined by ILAC, which is another international organization. There's another ISO standard other than 17025, and this is called 17043, and this actually outlines the requirements for the proficiency testing providers. So the people who are sending the samples out to the laboratories have another standard they have to adhere to as well. We can't provide like best practice or consulting or guidance necessarily, but we do have a document that helps laboratories to create and develop their proficiency testing plan, and that's available through our website, and it's called the G133. But it's really important to consider all of the risks that are potentially associated with each test when developing a PT plan or proficiency testing plan. So this could include things like a change in regulations, a change in personnel, a change in equipment or certified reference materials, or even a new matrix that's been added. So if a laboratory is routinely testing for flour only, and then they would like to add testing for gummies and chocolates, then it might be encouraged to increase the participation for those specific gummies and chocolates. If there's already been established proficiency for flour, then that might be less of a risk. So it's really all up to the laboratory to determine the risk, but it's most important for the cannabis testing laboratories to ensure that they're following their own state regulations as well.
Thank you for outlining those crucial accreditation requirements, Morgan. Now let's explore the regulatory landscape a little further. Morgan, given the diversity of regulations across states, could you provide insight into how often labs are required to participate in proficiency testing, and does this timeline vary from one state to the other?
This timeline definitely varies a lot from one state to the other. So we do see that some states require proficiency testing for every method on the scope every single year. Some states just require participation period. They say you must participate in some way. And then other states will actually select the provider of the proficiency test and tell the laboratories you must use this provider, you must use this schedule. And some other examples where there's requirements on top of the standard would be for the AOAC program, there's additional proficiency testing requirements. And then for states that are, I guess, TNI or ELAP states that include cannabis in that, such as Oregon, they actually have to follow the Oregon ORLAP state requirements, which does mandate a very high frequency of proficiency testing in comparison with other states. So it really does depend where you're located, how frequently you must participate. Again, some laboratories will have to participate every single test every single year, and some it's just really up to them how frequently they want to do it, as long as they're doing something.
All right. Thank you for providing those examples, Morgan, which really demonstrate the diversity in proficiency testing requirements across different states. Now, shifting gears, Morgan, let's explore the evaluation process. Could you walk us through the proficiency test results? Could you walk us through how proficiency test results are evaluated using statistical methods, and how proficiency testing providers interpret these results to determine whether a lab passes or fails proficiency testing?
So for proficiency testing providers that are accredited to the standard we talked about earlier, which is ISO 17043, there's various requirements related to the statistical methods that are implemented to determine a pass or fail result. What I've seen is that for cannabis, some of these values are based off reference materials. So essentially, this would be a certified reference material of an analyte, such as a pesticide, that is spiked into the matrix of flower, and then that would be distributed out. In this case, there would be a known reference value associated with that sample. The acceptance criteria to determine pass-fail may be up to 40 to 60% deviation from this true value, and it's basically up to the provider to determine the results, and they can do this based upon the participant results. So if a provider sends out or sets a schedule for a cycle of proficiency testing, they don't know ahead of time if they're going to have 10 participants or 100 participants, and they don't know what the results are going to be, but they do have to determine ahead of time how they're going to determine this pass-fail designation. And most proficiency testing providers use the ISO 13528 standard, which is the standard for statistical analysis of proficiency testing results. That being said, I did want to share a couple of examples that I have seen where proficiency test results do not necessarily align as well for some analytes as they do for others. So the examples I wanted to discuss were total yeast and mold, moisture, and cannabinoids. So these are three pretty important tests. The total yeast and mold can prevent a product from making it to the dispensary and to the consumer. And again, this is a consumer safety test. So at the end of the day, the government, the state government, is trying to prevent any exposure to this yeast and mold. So a sample was sent out to multiple different participants. And for I have two examples. One, the assigned value was 3,342 colony forming units per gram, and then the accepted results went all the way from 0 to 12,000. In another example, the assigned value or the true value was 58,477 colony forming units per gram, and the accepted values went from 28,800 to 113,000. So this kind of shows that even for this highly regulated industry where the regulator has a very strict cutoff for total yeast and mold allowed in the product, that the results from the laboratories are actually highly variable for this method. Another example that I wanted to highlight was for moisture. And so the reason a moisture test would be important for cannabis flower is because the moisture is generally factored into the final cannabinoid and terpene results that a consumer would see on a label. So they actually take out the percentage of water that would be in the sample, and that's called a dry weight percentage. So this moisture percentage that's taken out is usually done by some type of drying method where the flower is dried for a period of time, although there's a ton of methods that you can use to achieve a moisture result. The values that I saw in 3 different reports ranged from 4.16% moisture to 13.26% moisture. Another one ranged from 9.42% to 21.98%. And the third example, the accepted range was from 4.98% to 22.34%. And just to kind of give an example of how this could then lead to a change in the label result. If we took that 4 to 13 example, the difference in a cannabinoid percent could be about 3% different if the flower was listed at 20.87% with the lower moisture. Then as the moisture goes up, the cannabinoid percentage would also go up because you're taking out more of the moisture or more of the water. So that actually bumps the cannabinoid value from 20.87% to 23.06%. And then the last one I wanted to point out was there's a new study that's available with high THCA flower, which is actually available to be distributed across state lines if the laboratories are appropriately licensed with the DEA. And in this study, the THCA values that were accepted were 2.516 to 10.064. So this is another area where there was a good amount of variability between the participant results. And I think it's really important for consumers to kind of realize this when they're making decisions, because the numbers on the label might not be 100% exact. There's always some uncertainty tied to it. And looking through some of these publicly available reports can really show you what that variability might look like, even in proficiency test samples in practice. So 2 websites where they do publish these reports is the University of Kentucky's website for their hemp proficiency testing program, and also Emerald Scientific publishes their reports as well. They have the fall 2023 reports available through the Emerald website.
Great. Thank you. Thank you for the examples as well as the resources, Morgan. Next, I think it would be interesting for our listeners to understand the complexities of test accuracy and reliability. Morgan, how do matrix interferences and sample heterogeneity impact the accuracy and reliability of test results? And what measures should lab take to minimize their impact?
So this is a great question. The matrix interference and heterogeneity does definitely impact the accuracy and reliability of test results. One example I really like to just start off with here is if anyone's familiar with diamonds and sauce. This is a matrix that's available in dispensaries across the United States. And essentially there is like a crystal structure and a sauce structure to it. And the sample as received by the laboratory would have literally like a crystal in it and sauce in it. And depending on how the laboratory is actually mixing the crystal and sauce together, or if they're just taking the crystal part or just taking the sauce part, they might be getting totally different results. And this is because the cannabinoids are all in the crystalline structure and the terpenes are all in the sauce structure, which is the more liquid structure. So essentially, if a technician is mixing it up super well, then they're going to get pretty even results. If the analyst is taking only the crystal part for cannabinoids or only the sauce part for the terpene analysis, then those results are going to be a little bit inflated. If it was reversed and for some reason they took the sauce part and tested that for cannabinoids and the crystal part and tested that for terpenes, then the results would be deflated across the board for both of those. So that's just one example of like a real life matrix where this could be impactful, and that does not even take into consideration all of the editors that are available. That's just one easy concentrate essentially. But by nature, this can have an additive or reductive effect on the analysis. And another example where this could happen is for specific edible products. There's like food dyes that might interact with certain pesticides. There's ion suppression that can occur where it may appear that a pesticide is not present even though it is, or it may be inflated even though it's not supposed to be that high. So it's really important for the laboratory to consider these factors when performing their method validations or verifications, and to consider these for each analyte, and if there's any specific analytes that may be of concern. So if a laboratory is participating in proficiency testing and they're failing for one analyte over and over and over again, it may be some type of matrix interference that's occurring there, and there could be some, I guess, more digging into why that could be occurring. So another thing to really consider is when a state is going to be adding a new matrix, there's a couple of things that the laboratory should really be looking at with their existing methods. Like, are their existing methods suited for testing this new product type? A lot of this comes down to the industry not having great definitions for homogeneous samples and for matrices. So each state, the sampling is totally different. So in some states, the laboratory will go out and collect a sample. In other states, the grower or processor will deliver a sample to the laboratory. In other states, there's a third party that does sampling, and the laboratory and the grower or processor is actually not even involved. So just from step one, there's kind of a lot of variability there. Once the sample actually gets back to the laboratory, then there's an additional homogenization that can either take place or not take place with certain intensity depending on how the laboratory is going to homogenize their sample. So there's just really a lot of variables out there, and that's not even getting into things like chocolates and lotions and bath bombs, and we're not just talking about flour and concentrate anymore. So this really also comes down to the processors having good manufacturing practices. And so if they are not able to create a completely homogeneous lotion or bath salt or cosmetic or peanut butter, then the laboratory really has no chance of getting a homogeneous result because they're not getting a homogeneous sample. So there's really a lot of factors at play here. From my personal experience, we would test gummies sometimes, and we would get gummies from a processor, and basically you could test one gummy and a next gummy and get two completely different results. So if the laboratory is testing the gummies individually, they might be getting a different result who is like melting them all down and combining them or cryo-milling them together. Additionally, some gummies are actually coated in a sugar that contains the cannabinoids, so then it depends how much sugar is on each gummy, how well did you homogenize the sugar cannabinoid stuff into the gummy, did you take a tiny little sample from the inside of the gummy and not even get any of the sugar on it. And these sample sizes that are being used to test are really small compared to the actual gummy itself. So if you have a gummy in your hand and you're thinking like, oh, you just put that whole thing in an instrument and test it, it's not really like that. You really do have to kind of subsample these things. And then another variable here is the state regulations for a lot size. So some states will have one lot is a certain number of pounds, right? And that can, this sample that the laboratory receives is supposed to be representative of how many pounds of product. Well, that also changes from state to state. So it's possible that in one state, they're actually sampling twice as many samples to get a representative sample than in another state. So in that first state, you could be getting two sets of results that are kind of similar, whereas the second example, you're really only basing your entire lot off of one result, and so you're really hoping that that one result is representative and that the sample is uniform and that the lot is uniform as well. And this does come into play in other industries as well. It's not just the cannabis industry, but I think one thing that the cannabis industry here is lacking is that GMP, the good manufacturing processes. There's not really as much regulation on the processing and the growing aspects at this time, at least. I hope that answers your question.
Oh, that does, that does. Thank you for such a detailed explanation, Morgan. Morgan, clearly addressing matrix interferences and sample heterogeneity requires careful consideration. And thank you for touching upon the point of a lack of regulatory practices, good manufacturing practices. Morgan, building on the discussion, let's explore the protocol for laboratories encountering difficulties. Morgan, in the event that a laboratory fails proficiency testing, what is the recommended procedure for review along with a plan of action to correct the problems found?
Great. So I just want to reiterate, I can't really speak to what a laboratory should do or provide consulting or guidance. However, according to the standard, when a laboratory does fail a proficiency test, they'll be opening a corrective action or a nonconformance in association with this failure. And part of that is going to be finding a root cause as to why this happened. There could be a ton of different root causes depending on the situation. It could have just been an entry error, or it could be a method issue. It could have been an issue with the instrument, the calibration. It's really kind of a case-by-case basis, which is why the laboratory should look into that specific example and determine, why did this happen? And once you find out why it happened, then you can kind of come up with a plan on how to prevent that from happening in the future, whether that is through changing a procedure, additional training, maybe some additional instrument verification, maybe a pipette was out of calibration. It really could have been any number of things. That being said, I do want to stress that when you look at a PT report and you get one back from the provider, it's possible a lot of laboratories are just kind of looking at the pass fail and not looking any deeper. But I think there's really a lot of great information in a lot of the reports. Each provider does have a different kind of framework that they use and the information that they're willing to provide in the report, and some provide more than others. But it can be helpful to see not just if you failed, but how you failed. Did you fail high? Did you fail low? Did you fall kind of in the middle of a bunch of people that also failed, or were you like the very last final value or the very first top value, being like the highest or lowest numbers there? So these are all important things to consider. And it's also like on the flip side, not all sunshine and rainbows just because you pass. So earlier I gave some examples of passing values that ranged all the way from 2 to 10 for THCA percentage. So if you passed and you got a 2, or if you passed and you got a 10, I mean, it's great that you passed, but there still could be more room for improvement there to try to get better alignment with the results, and to kind of look into maybe why your value was on the higher end or on the lower end. So I think really looking through the report is really important, and also trying to find out how the provider is determining the pass fail. Was this a consensus based? Did they get 100 participants and they incorporated all of the results? Did they get 10 participants? Was this a reference value, so the true value was actually determined before the sample even went out? So there's really a lot to consider whether you pass or fail.
Right. Thank you for the insights, Morgan. Let's discuss some examples of how proficiency testing has positively impacted lab operations or enhanced their credibility. Morgan, could you share some practical instances where proficiency testing has directly contributed to enhancement of lab operations, cannabis lab operations, or enhancement of credibility of labs?
Sure. So I think proficiency testing really helps the laboratories to assess their methods and their personnel, as well as their instruments and their performance as a whole. So it can help an individual laboratory greatly, but I think it can also help the industry. And this is definitely seen in the cannabis industry, but I think a great example to tie it back to would be environmental testing. So in the environmental testing world, all the laboratories that are accredited through ELAB must basically submit their proficiency test results to a database. And this can be looked at to see if there's any analytes that are of concern across the board. So if something like this could be done with cannabis, we can see that there might be certain pesticides of concern, or there might be certain microbes of concern. A great example that I dealt with was vitamin E acetate. So originally, the laboratory I worked at was not testing for vitamin E at the time. It was not regulated. Essentially overnight, the regulator decided that they're going to start testing for this new analyte. And so as a result, we have to then develop and validate a method for this. And participation in proficiency testing was really helpful in that case to determine that, yes, the method that we have developed is in alignment with the other results from the participants. But I think this could be really something that it continues to improve over time and has definitely improved just over the past couple of years as far as what is available for the laboratory. So it used to be, and it still is to some extent, challenging to find certain options for proficiency testing. Like, it might be hard to find a chocolate a couple of years ago. Now it's a lot easier to find a chocolate in a gummy, but it might be kind of hard to find like a lotion or a bath salt. So there's definitely a lot of room to grow for the proficiency testing area for cannabis. We're not anywhere near what the food industry looks like right now, where you can find like a proficiency test for any food that you can imagine with any analyte that you can imagine out there by 10 different providers. So we're not quite there yet, but we're definitely well on the way, and it's much, much better now as far as the options that are available for the laboratories to purchase, and as well as the information that the laboratory is getting back from the providers. One thing that I did want to just throw out here as well is if you're a laboratory and you have a question or a concern or a request from a provider, at least in my experience, all the providers that I have spoken to have been extremely welcoming, and they want feedback. If there's something that you can't find, it doesn't hurt to reach out and ask because they want to improve too, and they definitely want the whole industry to kind of move in the right direction.
Right. Morgan, considering the complexities of cannabis testing, what are the limitations of proficiency testing for cannabis testing labs? And furthermore, how can proficiency testing be improved for cannabis labs?
So one of the main limitations right now is definitely the federal illegality of cannabis. As we discussed, the high cannabinoid samples can't really cross state lines currently unless you're a DEA registered laboratory, and then there's all these special permissions and forms and hoops to jump through in order to basically be compliant there. So currently, the samples that are used are very low in cannabinoids, and so this is definitely a limitation because some of these cannabinoids could interact with other analytes such as pesticides, and it's also difficult to determine the laboratory's proficiency at high concentrations if they're not getting high concentration samples in for proficiency testing. Another limitation that kind of coincides or aligns with that is that the state regulations are all different. So if one state regulation wants a laboratory to be proficient at testing 100 colony forming units per gram of E. coli and a different laboratory wants proficiency at 10, then this doesn't really align, and it's hard for a laboratory to find a test that's going to align with their specific state action limits and regulatory limits. So this kind of makes it challenging, and some providers have kind of stepped up to the plate here and said, okay, I'm going to make a pesticide proficiency test that's specific for Florida and one that's specific for California. But that's not really the ideal framework because, ideally the laboratories in each state would be able to be testing the same analytes around the same action levels, using the same samples and getting the same results. But today that's not really the case. I also think, there's some like catching up to do, which is a big limitation because the industry for cannabis has moved so quickly from being, the DARE program and cannabis being completely illegal to it being medical, to it being recreational, to basically you can go to a dispensary and get like hot sauce.
Yeah.
There's a lot of catching up to do, I think, for the laboratories, for the providers, and maybe some of the processors got really excited, and that's great, but they got a little ahead of themselves, and that's okay. But we definitely have some catching up to do. And then another big limitation for cannabis specifically is the spiking. So basically, when most samples are sent out, there's like I was mentioning earlier, a reference material that's spiked into the sample before it's sent out. It's not naturally contaminated with a pesticide it's not naturally contaminated with mold. They're adding to it. And for some analytes, this actually makes it very difficult to get a good test, and that would be for primarily quantitative microbial results, but also for some residual solvents and pesticides, because they can actually degrade over time pretty quickly. So the laboratory has to spike them and then test it immediately, as opposed to having a naturally contaminated sample that they would be getting from a grower processor, where they don't have this additional spiking and then homogenization step. So I think that's one limit that's going to be kind of hard to overcome. A lot of the providers have kind of struggled with this, and we'll see what they kind of do to address this as a concern. But that is one thing that we hear a lot from laboratories, is that they don't really like the whole spiking thing. They just want the sample to come in the same way it would come in from their clients. And then the other limitation, like, is just all of the matrices catching up to. We're constantly going to be running behind where the processors are. So they came out with hot sauce today. Next month they're going to have something else, and we aren't even caught up to what they started making last year. So the possibilities are really endless, and that can be both a good thing and a challenge.
Right. Thank you, Morgan, for highlighting the current limitations and potential areas of improvement in proficiency testing for cannabis testing labs. It's evident that the landscape is evolving. Morgan, given the federal illegality of cannabis, do you think proficiency testing is more challenging in the cannabis industry as compared to some other industries, like perhaps the food industry? I know you mentioned the food industry is much more mature, but in what specific aspects do you think this is happening?
So I think we kind of already discussed a lot of the more scientific or technical aspects of why this is happening, but there's another aspect of this that I did want to touch on, other than the federal legality of crossing state lines, other than the low cannabinoids and the tons of matrices. I think that there's really been a lot of adverse attitude towards cannabis from these large providers, because partially of the federal legality, of course, that I wasn't really expecting. So there's a lot of established providers for the food industry and the petroleum industry that basically won't touch cannabis or won't add it to their repertoire. Or if they do have it as an offering, it's not really a focus for them because they're already well established in other industries like food and environmental. So this is something that I wasn't necessarily expecting to encounter, but I definitely did encounter it. That being said, there have been a lot of providers just over the past year who have added cannabis to their repertoire, and I was not necessarily even expecting that to happen. So I made a presentation back in like 2022, 2023 of all the providers that I could find for cannabis proficiency testing. And then when I went to update it in the end of 2023, beginning of 2024, I actually had a bunch to add. And I was really happy about that, because that means that just over the 1 year period that I wasn't working on it, there's actually a bunch of new programs that are being offered. And so that's great. And we're seeing these organizations like AOAC and ASTM offer cannabis-related proficiency testing, but there's still some companies that are pretty shy to offer this, or pretty shy to advertise that they're offering this.
Mm-hmm. All right. Thank you, Morgan. Morgan, looking ahead, as cannabis testing requirements continue to evolve, what advancements or developments do you foresee in the field of proficiency testing for cannabis labs?
I would definitely anticipate that there's going to be some new analytes or contaminants of concern that might be brought up over the next decade or so. This could include things like synthetic cannabinoids, or cannabinoids that are phytocannabinoids that we're just not testing for yet. Of course, with any agriculture industry, there's going to be brand new pesticides every week. But, you know, I think one way that this is going to evolve, as we talked about, is with the additional matrices like hot sauce and gummies and lotions and bath salts and stuff. I do see potentially more options being available. And it's also possible that there's things that we're testing for today that we find out are not a risk to consumers that we then stop testing for. Or there's things that we have no idea that's a risk to consumers today, but we find out, through potentially adverse events or through consumer feedback that something happened either medically or some bad experience happened, or even a new compound is discovered that has a benefit to the end user. And this analyte could be tested for that we're not even aware of today. One that, or two, I guess, that would come to mind for me are flavonoids and vitamin E. So when I first was testing with cannabis, I never really tested vitamin E, and as I discussed, it was kind of just an overnight regulatory change that this is a contaminant of concern, we're going to start testing for it now. Another one that has come up in a more positive light has been the flavonoids. So everyone is saying, okay, a lot of consumers are making their purchase decisions based off cannabinoids and terpenes. Now there's actually this additional flavonoids compounds that can be tested for in some states. So yeah, I really think that these types of things will evolve. And additionally, it's possible that we see some type of plant virus testing coming. So the hops latent viroid has been detected in a lot of cannabis plants. And to avoid some of the agricultural issues that we've seen for like citrus greening in Florida, it's possible that laboratories or states even start mandating testing for plant viruses. Or additionally, it could be possible that there's genetic testing in the future to have a specific strain identification that they don't currently have today. It could be that regulations change in regards to what you can call certain flower and what naming conventions that you can use. So it's possible that there will be genetic testing down the line as well. And one additional thing that I think could happen is there could be increased environmental testing within the actual grow facilities as well. So this is something that's not really currently regulated or mandated, but a lot of the growers and processors are actually interested in finding their point of contamination. So doing like a hazard analysis, critical control point, finding out, okay, well, if we have this mold in our flower, where is it coming from? Where is the source of this? So some of that environmental testing could potentially be added for the cannabis industry in the future as well. So yeah, I think there's definitely, it's going to be an evolving industry for a while, and we're still going to be, learning every day.
Thank you for the insightful perspective, Morgan. Morgan, as we wrap up our discussion today, let's explore the role of informatics tools in supporting proficiency testing for cannabis labs. Could you elaborate on how these tools support proficiency testing processes and contribute to the overall efficiency and efficacy of cannabis testing operations?
Sure. So one really important thing in the ISO standard is for 17025, which applies to cannabis testing laboratories, and again, laboratories in all industries, is really the traceability. So when a sample comes in and you have to weigh the sample, you have to get a subsample and weigh that. So these are sample weights that you're dealing with. Then you add this sample into eventually an instrument. The instrument then has its own software that processes it. And really a LIMS or an informatics tool can kind of be integrated into these systems to help the laboratory track performance over time. And this is not just for proficiency test samples, this is for compliance samples as well. But one of the requirements regarding proficiency testing is that proficiency test samples should be treated like routine samples. So when a proficiency test sample arrives to the laboratory should be treating it as if it came from one of their clients. The best way to do this would be to process it through the system the same way you would with any normal sample. And this would mean entering it into this LIMS database, which does record all of the user actions, data modifications, and system events that could be associated with this. And this could then help if the laboratory does fail in the future to go back and determine what your root cause was, because you're going to have so much more information to look at about the process as the sample was received to the laboratory, processed, who processed it, which scales did they use, which pipettes did they use. Then they put it in the software. Okay, well, what did they input in the software? What order were the samples in? Things like that. So it can really be helpful looking backwards and also for trend analysis. And then another way that this tool can help is by standardizing the workflow. So another kind of requirement for proficiency testing is that, let's say you have 7 analysts who are all trained to do microbial testing. It's not that the same analyst should be doing the test every single time you get it. It should really cycle between the different analysts. So this is something that you could potentially set up ahead of time and pre-schedule through this database and determine which analyst is going to be dealing with which proficiency test on which schedule, so that you are sure as a laboratory that each of your analysts have taken this proficiency test and been considered proficient for this method. So additionally, as I had kind of alluded to earlier, there's a couple of other industries that really use this on a very large scale. So this would not be an individual laboratory use, but this would be like kind of a nationwide or even international database. And this is done for the World Anti-Doping Agency as well as the NELAC Institute. So for environmental testing and for adulterant testing in athletes, all of the results are actually input into a database that is kind of more worldwide or countrywide. And so these results can really be kind of data mined and looked through using this kind of tool that wouldn't be available if we were all just kind of working on paper still. So I think there's really kind of endless possibilities as far as the implementation and the way the laboratory wants to use these tools. And definitely reach out to your LIMS provider and ask them, because I'm sure they have even better advice than I do.
Thank you, Morgan, for providing your invaluable insights into the potential applications of informatics tools. These tools offer ample opportunities for tracking performance, analyzing trends, and ensuring defensible results over time, as you said. Morgan, as we draw our discussion to a close, I want to take a moment to extend our appreciation for sharing your expertise and enriching our conversation today. Your insights have been truly enlightening. And thank you so much, Morgan.
Thank you so much for the opportunity. Again, I'm really happy to talk about this topic. I'm really excited for everything that's happened over the past couple of years, and definitely looking forward to the way this evolves into the future. Hopefully in 5 years we can do this again, and there'll be even more options and more things to discuss. So
totally. And to our listeners, thank you for tuning in. We hope you found the discussion informative and engaging. Your opinions matter greatly to us, and we eagerly anticipate your feedback. Do share your feedback on this podcast with us at support@cloudlims.com. And if you have any questions on the discussed topic or are in search for a reliable LIMS, you can reach us at 1-302-789-0447 or send an email to support@cloudlims.com. Thank you, Morgan. Thank you, listeners. Bye for now.